do it a little bit more. So I'm going to go through this particular question over here. I'm going to start by saying proof. In triangle A, oh, no, look, I'm drawing another triangle. In triangle ADC, teacher Coco, in triangle ADC and triangle CBA, I'm going to start with number one. If I'm looking at this picture here, I can tell that these are parallel lines, and I know parallel lines means fun angles. So I'm going to look for my fun angles. I'm going to start by doing that. Yeah, there's an N, and that tells me that angle A1 is equal to angle C2. And my reason for that is going to be alternate angles. And then remember, when I use alternate angles because of parallel lines, I always need to make sure that I name my parallel lines. So I need to say that AB is parallel to CD. Okay, that's the first one. Okay, my second one is going to be those two parallel lines, those that go that way. And they also make an N. And that tells me that angle A2 is parallel to angle C1. And I can always equal to angle C1. It's also alternate angles. And my parallel lines now are line AD is parallel to line BC. Okay. And then the last thing I can see between these two is that they both share this line. They both share this line AC. So I can then say that AC is common. Now, I don't need a reason for that one. We can just tell by the picture, the way the quadrilateral has been drawn, that they actually are equal. And now over here, I've got an angle, I've got a side. But that doesn't necessarily mean that my reason for congruence is going to be angle, angle, side. So let's have a look. I'm going to say, therefore, triangle ADC is congruent to triangle CBA. CBA, or am I lying? It's CBA. Yes, it is CBA. Right. And my reason for this, now, if I look at the way that my picture has been structured here, my quadrilateral has been structured here, I know that there's an angle over there. In this triangle, there's an angle, and there's an angle, and there's a side in between them. Same with this angle or this triangle over here. I've got an angle over here, an angle over there, and a side in between. So what is my actual reason for congruence over here? Who can tell me either in the chat, or you can unmute and let me know, what would the reason for congruence be in this particular question?
The angle is side angle.
Beautiful. Absolutely, Mandisa. Good work. It's angle, side angle. And Desmarie got it as well just in time. Wow. Excellent. So that is the reason, because there are two angles with a side in between, the side has to come in the middle. So it's angle, side, angle. Excellent work, peeps. All right. Welcome to MathsLive this afternoon. I hope everybody's doing well. Okay, let's get into today's lesson. I hope everybody's ready. We're going to look at a bit of congruence. I'm just going to quickly go through the rules one more time. We're going to look at the rules or the reasons for congruence over here. So if you haven't already taken a screenshot of this, please make sure you take a screenshot of it. You're going to need it. Hi, Palisa. Good afternoon. All right. Okay, what we're going to be doing quickly, we're going to be going through this proof over here. So this question here says, prove that triangle ABM is congruent to triangle DCM. And I want you guys to take some time and quickly just go through this and see if you can find the reason. Okay, I'm going to give everybody about 3 minutes to go through this. Remember to follow the steps, guys. We need to start by saying proof. Start by saying proof in triangle something and triangle something. Give me 3 reasons, or give me 3 statements and reasons, and then you can say, therefore, triangle ABM is congruent to triangle DCM, and then you must give your reason. You must tell us why they're congruent. What is the reason for congruence here? Okay. I'll give you guys a second. I just want to check something quickly. I just want to see. Oh, yeah, that's not going to help. All right, we're going to leave it just here. Okay, pop your favorite emoji in the chat when you're ready. Okay. Okay. And I'm going to explain to you guys why ma'am emphasizes that we need to map out our triangles correctly in today's lesson, because today's lesson is actually about similarity and not about congruence, but we will get there. And it's quiz day, so yay for that. We're going to go to quizzes. Okay, good, Michael, but I want you to do the proof for me, and then we'll discuss after. So let's not give away the answers, okay? Just pop your favorite emoji in the chat when you're ready, okay? Sure, Oko's already done, which is lovely. You can see your emoji there. Mandisa's also done. Yo, you guys are super fast, hey? I just finished my sentence and people are already done. Sure. All right. Okay, I think that's enough. I was going to give you guys 3 minutes. It looks like it only took everybody 2 minutes to do, 1.5 minutes to do, clearly. So let's go ahead and work through this proof. All right. I want you guys to note over here that they've started prove that triangle ABM. So if I start at A and I go to B, do you see how I move past the side with nothing? And then I move past the side with 2 lines, right? That means in the other triangle, I need to start at this point, go past nothing, and go past the lines with 2 lines, the side with 2 lines. So I need to say in triangle ABM and triangle DCM, first one that we can look at is what they've given us. They've told us in this that AM, side AM, is equal to side MD or DM. It won't make a difference whether you write MD or DM. And the reason for this is that it is given. Okay, they've given it to us. Then they've given us side BM is equal to side MD. Oh, no, CM or MC. Shoo, MC. That is also given to us. Okay. Then I can see here in the middle that I've got 2 lines, transversal lines here, and those 2 angles are going to be equal to each other. So I can say angle M1 is equal to angle M2. And the reason for that, it's not given. They haven't given it to us. In this case, we have to state the reason for that. It is vertically opposite angles. Okay. Then I have to go and look at my reason for congruence. Now, I see here in this first triangle, I've got a side, and I've got an angle in between. And on the side, I've got a side, and I've got an angle in between. So that means I need to have a side, and an angle in between. Okay. Ooh, remember, Tanduluchi, SSA is not a reason, hey? SSA is not a reason. We can't use SSA. Okay. It needs to be SAS. Okay, remember, I've got a side and an angle in between, so side, angle, side. All right, be very careful there. It's very important that we get it correct. Okay, I would just like to check in with you guys. Give me a thumbs up. How are we feeling, or thumbs down? How are we feeling about congruence? Are we all good? Are we doing okay, peeps? Yes.
Doing
Thank you,
good.
Tanduluchi. Michael, Okos, I heard that good. Okos says yes. All right. Okay, remember, guys, if you need any help, stop me anytime. I'm seeing Buikanyo crying. Oh, my darling, were you here on Monday? Let's check quickly. If you weren't with us on Monday, then this might be a little difficult for you, okay? Yeah. Desmarie, I'm going to start calling you hashtag for now. I think Desmarie's new name is going to be hashtag for now, because every time I say something, I'm like, do you guys understand? She's like, yes, ma'am, for now. So I think I'm going to start calling you hashtag for now. I love it. I love it. Okay, Buikanyo, my darling, please ask as many questions as you need, okay? But also, if you weren't with us on Monday, I'm going to ask you to go watch Monday's lesson. It's very, very important that we get it. All right, let's get into today's lesson. I'm just going to ask before we get going, there's someone named Zoom user. Zoom user, if you could just pop your actual name in the chat so I don't call you Zoom user, that would be wonderful. Okay, I want to call you by your actual name and not just Zoom user. Okay, sure. Okay, nice thing about today, Buikanyo, is that you don't have to have watched Monday's lesson to understand what we're doing today. Okay, and that's the nice thing about today's lesson. Today, we're going to be talking about similarity. Okay, so when we talk about similar triangles, right, they're going to differ in a big way to congruent triangles. Who can remind me? What did we say congruent actually means? When we say that two shapes are congruent, what did we say they actually are? They are what?
Identical.
Oh, love it. They are identical. Absolutely. They must be identical. Now, we're going to run into a little bit of a problem when it comes to similar triangles in that they're not identical. They're not. I'm going to have a triangle like this. And then I'm going to have another triangle, and I'm just going to take this one and copy paste. And my triangle is going to be like that. Now, obviously, these are they're not identical. They're not identical. One is bigger than the other. One is bigger than the other. So our similar triangles are in fact similar, but they differ in size. Okay, they differ in size. But there are certain things that we know about triangles that are the same, are similar, but differ in size. There's some things that we're going to get into here. If we look at the examples that ma'am has put on the screen here, we can see that this triangle, we'll call it triangle A, B, C, and we'll call this triangle D, E, F. Right, if we look at triangle A, B, C, and D, E, F, they're not the same size, but we know that this indicates that they have the same what? What do they have the same of?
Angle.
In size. Correct, they have the same angles. The angles are equal, right? Same with this one, even this one over here, angle PQR. They all have the same angles. But we know that because they have the same angle, that doesn't mean that they have the same size. What we do know is that E is going to be some version, like maybe half of B. We also know that F is going to be maybe, we don't know, half of C. And D is going to be maybe half of, or a third of, or a quarter of A, right? So when we look for similarity or similar triangles, what we're going to say is that the angles in similar triangles are equal, right? But the sides are not equal. What do we say about the sides? The sides are what? In what? It's also called a ratio. I'll tell you that. It's also called a ratio. What's another word for ratio?
Size.
There we go. Cat's got it. That's it. Good cat. That's a Desmarie. Not in size. The sides are in proportion. Okay. And I'll explain a little bit more what we mean when we say that the sides are in proportion. What we mean is, if, let's say, for instance, this triangle is half of the size of this one, if C was equal to 10 centimeters, then F would equal 5 centimeters. And if A is equal to 6 centimeters, then side D would equal 3 centimeters. And if B was equal to 12 centimeters, then side E would equal 6 centimeters. Now, if I had to put these over each other, I should be able to get the same proportion. So let's take C over F. If I take the size of C, or let me do it the other way around. Let me say F over C. F over C. If I take F over C, F is 5 centimeters over C, which is 10 centimeters. If I simplify this, I'm going to get that they're in proportion of 1 over 2. Now, if I do the same with D, I'm going to take D over A. D over A is going to give me, if D is 3 centimeters and A is 6 centimeters, they also give me a proportion of a half. I'm going to do the same with E over B. E over B is equal to 6 centimeters over, oh, let me close this. I didn't even see that that was open. 6 centimeters over 12 centimeters. And if I look at the proportion of that, that's also 1 over 2. So when we say that they're in proportion, it means that they've either been doubled or tripled or quadrupled by the same number on all the sides. Okay, and that's what in proportion means. And these are the only two ways we can prove similarity. Unlike congruence that has side, 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 and side, angle, side, and angle, angle, side, and RHS, no. For similarity, we only have two ways to prove that our triangles are similar. We are either going to use the reason angle, angle, angle. That is if all the angles correspond. Or we're going to literally say sides in proportion. Those are the only two ways we can see if the two match. But it's very important, again, that we map out our triangles properly. Okay. I don't like the way that this thing has been numbered. I'm going to do it this way. I'm going to say this is D, this is E, and this is F. Okay, so if we look at this, if we are to say that these two triangles are similar, we're going to say that these two triangles are similar. I'm going to first map out my triangles. I'm going to go in triangle ABC. So I'm going to go triangle ABC and triangle. Now, I want you guys to note that I've started at the top and I've gone left. So in this other triangle, I'm also going to have to start at the top and go left. So I'm going to say in triangle ABC and in triangle EFD. Okay. We're going to look at the proportion of these. Because we don't have any angles, we're going to use proportion. I'm going to say that side AB is in proportion. Which side is side AB in proportion with? Tell me, guys. AB is in proportion with which side? Of the other triangle, by the way. Correct, Sanelli, so beautiful. With EF, good. AB is in proportion with EF. And that should equal the same proportion that I have for side BC. BC is in proportion with which side?
FD.
FD, beautiful, yes, absolutely, is in proportion with FD. And then that should also equal the same proportion that I would get for AC and which other side?
ED.
ED, beautiful. So AC and ED, excellent. AC and ED should be in proportion. Okay, now the reason why ma'am is a stickler for the fact that your triangles must be in the correct order is because if they don't give us a drawing, let's say for instance, this drawing doesn't exist. I'm going to take all of this and I'm going to move it over to the side. I'm going to move it over to the side. I'm going to show you guys what we're going to do with all of this. And there now I've stolen the E. I'm going to move away from this. If I can't tell, if they just give me this and they say, tell me which sides are in proportion. If they want me to tell you which two sides are in proportion, here's what I'm going to do, guys. I'm going to go to my triangle and I'm going to go side AB needs to be in proportion with side EF. Do you see how the first two are in proportion? So AB needs to be in proportion with EF. Then I'm going to go to the next two. I'm then going to say side BC. Which side would BC be in proportion with? BC needs to be in proportion with?
With FD.
FD.
Absolutely, FD, those two. FD. And then that tells me that side AC AC would need to be in proportion with
FD. ED. Sorry, ED.
ED. There we go. You got it, my darling. ED, all the way to the end. ED. So, do you guys see, if they don't actually give us a drawing, we can actually use the correct order of our triangles to figure out which sides are in proportion. Give me a thumbs up. Is ma'am making sense? Okay, because they're not actually going to tell us. Sometimes they're not going to tell you which triangles are in proportion. You need to figure it out yourself. Okay, so if you haven't mapped out your triangles properly, you're going to give them the wrong proportions. Okay, and that's going to affect your whole answer. So we need to make sure that we're getting that 100%, guys. It's very, very important. Okay. Beautiful. Good, Wikanyo. Well done. All right. So let's look at these questions over here. It says here, we've mapped it out properly. Just going to put the E back in the question. E, right. It says here, if these triangles have the same orientation, side AB corresponds with side what? What side does AB correspond with?
Ma'am, is it not EF?
It is EF. You are 100% correct. Well done. Side AB corresponds with EF. But also, the angles would need to be equal. So angle A would correspond with angle what?
E.
Angle A would correspond with angle? E.
E.
Good. Right. Side BC corresponds with side what?
FD.
FD. I love it. Therefore, angle C
D.
correspond with
D.
Excellent. We're off to a great start. We're off to a great start. Now, let's look at an example of what this is going to look like. Because what we're actually going to do is we're going to have to prove some of these things. It's not just like we're going to look at it and then we're done. Okay? That's lovely and all. That's lovely and all. Let's look at this question over here. This is an example. It says here, if in the triangles above, angle A is 84 degrees. I'm going to put angle A 84 degrees. Angle B is 38 degrees. Calculate the value of all the other angles. Right. So we said that there are two ways to prove similarity. Either all my angles need to be equal. So I will get A, or I will get sides in proportion. Right. Now they're asking us to calculate the others. In order for us to do this, we are going to have to write our triangles in the correct order. Let's go ahead and do that. I'm going to start by saying in triangle ABC and triangle. Now, watch how I've mapped it. I started at A, I went to B, and now I'm at C. Right. If I look at this next triangle, this one, how would that one be? In triangle what? Yes, Michael. Beautiful. Good. In triangle MNO. And remember, I've got 3 of them. And triangle, thank you. Whew, Michael, you're on fire today. And triangle QRS. Okay. So it says here, if angle A is 84, what is angle M going to be equal to? Remember, they need to correspond. Angle A is equal to 84. That means angle M must also equal
84.
84, absolutely, 84 degrees. Which other angle must also equal 84 degrees?
Angle Q.
Beautiful. Angle Q must also be equal to 84 degrees. Good. Then we're going to go to the next one. It says here, if angle B is equal to 38 degrees, angle what must equal 38 degrees?
N.
N, yes. N, 38 degrees. And angle?
R.
Q, that's it. Beautiful. And Sally's given us the answer. Correct. Now, watch what? We know that N and R are also going to be equal. Now, watch the beauty of triangles. What do we know about the interior angles of a triangle?
They're equal to 180.
equal 180. Good. So can we figure out what C, O, and S equal? Yes, we can. Find me the answer. What is angle C then equal to?
58.
Thank you. 58 degrees. Thank you. And if 58 is equal to, I mean, if C is equal to 58 degrees, that means O is also equal to 58 degrees and S is also equal to 58 degrees. But we're not done. That's not all I want. Now, I want you guys to then tell me if these sides are all in proportion. Are we in agreement that all the sides are in proportion? Yes?
Yes, ma'am.
Because they all have the same angle. Because if the angles are the same, then the sides will also be in proportion. So that tells me that AB is in proportion with, we're just going to use, let's just use these two triangles. AB is in proportion with which side?
MN.
Yes, absolutely. AB is in proportion with MN, which should also equal BC in proportion with
O.
NO.
NO, good, NO, which should also equal AC in proportion with
MO.
MO. You guys are doing great. Okay. Excellent work, guys. Amazing work. Okay, so now let's fill in the numbers. We know that AB is equal to 2. And MN, we don't know what it is. We know that BC is equal to 4. And NO is equal to 12. Right. Now, because they're all in proportion, we can actually look at what's been done here. How did we get from 2 to 4? What did we multiply by?
2.
2.
By 2. Beautiful. We've multiplied by 2. So by this logic, we can then figure out that MN is equal to what?
6.
Excellent. Wow, wonderful. So we know that the proportion on this side is 6. Right. Now, if we look at MO, we know that MO, you can, absolutely, Sandy. So you can cross multiply. It's just that this one is easy enough for us to see. In the other questions, we will cross multiply to get the answer. Okay. In the other questions, we will cross multiply. Now, in this particular question here, we can tell that MO is equal to 15. Now, in this question, we are going to have to cross multiply. Saneliso is correct. Okay. Now, to get from, I'm only going to use those two. Okay. I know that the proportion of BC over NO is 4 over 12. To get from 12 to 15, I would have had to multiply by something, which means I need to multiply by the same thing up here. Okay. I've been doing this a while. I can tell that this is by 1.25, but that's not the reason. That's not the idea here. If we can't tell how we've gotten from that to that, then we're going to have to cross multiply. We're going to have to go 15 times 4 and 12 times AC. Okay, 15 times 4 is going to give me 60 is equal to 12 times AC would give me 12 AC. And to solve for this, I would have to divide both sides by 12. Okay, divide by 12, divide by 12. What is 60 divided by 12? That's it. Thank you,
5.
Palesa. AC is then equal to 5. Okay, so that means that the value we're looking for over here is 5. Okay, so we can cross multiply. Saneliso, if you can see it, if it's an obvious number, like from 4 to 8 or from 4 to 12, you can just see, okay, I multiplied by 3. Then go ahead and do that. Okay, don't waste your time with cross multiplication. Now you're making things difficult. If you can see what the ratio or the proportion is, just write the answer. Okay, because as teachers, we know that you've taken the logical steps to get there. But if it's not that obvious, then yes, absolutely cross multiply. Is that okay, my darling? You're allowed to do both of those. Don't stress. Okay, lovely. Let's now look at some proofs because we're going to have to prove. We're going to have to prove. Let's look at this first one over here. Okay, it says here, Prove that triangle ABC is similar. Remember, congruent was this way. Congruent was 1, 2, 3. Now, similar is just that way. Okay, those are the symbols that we use for congruence and similarity. Okay, now they say, prove that triangle ABC is similar to triangle ADE if BC is parallel to DE. Who can remember, whenever we see parallel lines, what do we need to think? Parallel lines? Yay! Absolutely, Mandisa remembered. Fun angles. Remember, our fun angles are your corresponding, your co-interior, and your alternate angles. Okay, so let's take it a step at a time, guys. We're going to start the proof as we do everything else. Proof. In triangle ABC, now watch, I've started at the top, A, B, I've gone to the left, and then across, and then up. And triangle, now they say ADE, so we're going to go A again, but we're going to go left to down to D, and then around and through. Okay, let's see how we can prove that these two things are congruent. A, D, E. Okay, for number 1, I'm going to use my parallel lines. Okay, what kind of shape do we see from our parallel lines here? Do we see an F, a U, or an N?
A U.
We do see a U, but it's a little problematic because I don't know what that angle is equal to, and I don't know what that angle is equal to. Remember, for U, we need to make sure that they're equal to 180. So that's not really going to help us. But Balissa is correct. We see an F. It's just an upside down F. Okay, there it is. You guys see it? It's an upside down F. Maybe let me make this a little thicker so we can see it. There. There. Does everybody see the upside down F?
Yes, ma'am.
Right. Good. So what does this tell me? Which two angles are going to be equal to each other? Angle?
Angle B1 and B2.
Correct. Not B1 and B2. B1 will be equal to
B.
D.
Oh,
D. That's
angle
it.
B1.
Absolutely. Angle B1 is equal to angle D. And our reason here, as Saneliso has said, is going to be corresponding angles. Corresponding angles. My reason here needs to be BC. Oh, sorry, not my reason. I must name my parallel lines. I now need to say that BC is parallel to DE. Okay. I'm going to go ahead and draw another F. But my F this time is going to be on this side. Okay, if I draw my F on this side, which two angles are equal? Angle?
C1
C1
and E.
and E.
Absolutely. Angle C1 is equal to angle E. And then again, it's because of the F. So that is corresponding angles. And then I can use the same parallel lines. BC is parallel to DE. Okay. Now, this is an angle. This is an angle. Oh, that's very dark. Let's not do that. This is an angle. Right. Now we're missing one more angle. Let's go to our triangles so we can see. We said that angle B over here would be equal to angle D. We've also said that angle C would be equal to angle E. What do we notice? What's left in our triangle? What do we see in our triangle? Yes, absolutely, Palisa, that A is common. That angle A is common in both our triangles. See, we used B and D. We used C and E. Now we can see that A and A, they both have A. So we can then say angle A is common. Okay. That tells me, therefore, that triangle ABC is similar to triangle ADE. Okay. Give me a thumbs up in the chat or with your reactions if you understand what ma'am has done here. Are we all good? Or you can say yes, ma'am, if you're unmuted. Ah, we can you love it.
Yes, ma'am.
Excellent. Good stuff. Right. Now, if my triangles are similar, that automatically means that they are in proportion. Saneliso, we cannot say that they share parallel lines because the lines, are the lines equal? Are they equal in length? The only time we'd be able to say something like that is if we were trying to prove for congruence. But remember, sharing parallel lines, unless it's incongruent somehow, it won't really help us. In similarity, we can only have equal angles and the sides must be in proportion. The sides being parallel doesn't really tell us anything. Okay? It doesn't really tell us anything. Okay? It doesn't help. Okay, so I now know that they are similar. So that tells me that AB should be in proportion with what? AB is in proportion with what side?
AD.
AD, absolutely. AB should be in proportion with AD. Okay, and then I also know that BC should be in proportion with
DE.
DE. Right, BC should be in proportion with DE. And that leaves the last two. AC should be in proportion with?
CE.
Mm-mm.
AE.
A. There we go, that's it. AC should be in proportion with AE. So we're going to skip AC should be in proportion with AE. Okay, so now the question we've got here says, if the length of AB is 6 centimeters, and the length of AD, so the length from here to there is 8 centimeters, and the length of AC, so from there to there is 9 centimeters, calculate the length of AE. Okay, so now let's look at where we've got a lot of information. Okay, I know that I want to figure out what AE is. So I'm definitely going to use, let me use a different color. I'm definitely going to use this proportion, right? Because I know that I'm missing AE. Which of these other two proportions gives us the most information? Is it BC and DE? Do we have any information on the length of BC and DE? Do we have the length of BC, guys?
No.
No, ma'am, we don't.
No, we don't. We don't. We don't have the length of BC and we don't have the length of DE. We don't. We don't have the length of that. So we can't use that one. Let's use AB and AD because we have the lengths of both of those, right? So to find AE, we're going to use that one and that one. So what I'm going to write here is I'm going to go AB over AD is equal to AC over AE. As long as they're both in proportion, because they're similar, we'll be able to find an answer. What was the length of AB again? AB was 6 centimeters over AD is
8.
8. And that is equal to AC, which we've been given as 9 over AE. Now, AE, we don't know. Okay, now we cannot tell, it's not obvious what the proportion from 6 to 9 is, so we can cross multiply. Let's cross multiply, guys, and figure out what AE is. So AE times 6 will give me 6 AE is equal to 8 times 9 is 72. And then I'm just going to divide both sides by 6. Give me an answer for AE, guys. Thank you, Palisa. Palisa says AE is 12. All right. Are we all okay with that idea, guys? Okay, so now we know that the length of AE from there to there is 12 centimeters. We've just figured it out, right? The next question says, what is the length of CE? What is the length of this tiny piece over here?
Three centimeters.
Centimeters, right? If the whole thing from there to there is 12, and from A to C is 9, then that tiny piece would have to be 3 centimeters long. Okay, let me ask quickly. I just want to make sure that everybody's still with me. Type in the chat for me quickly. On a scale of 1 to 10, how comfortable are we with proving similarity and proportions? Are we doing okay? Okay, Sanalisa says 7. Sally's at a 9.8. Ooh, Tanalotu is 15. I like it. I like it. Okay. I want us all to be okay, guys. We're going to try another example. Okay, good. If you're at a 7 or an 8, it just means you need a little bit more practice. If we're at a 5, we're definitely going to do another example together. So don't stress, guys. Okay, we're going to do another example together. Let's look at this one over here. Okay, prove that the following triangles are similar. And I'm going to add in there, give the proportions. Okay, do you see how in this particular question, they don't give us the triangles? They don't give us the triangles. So we need to figure that out. So let's start our proof. We're going to go proof in triangle. Okay, let's start somewhere. Somebody give us a
ABC.
triangle that we can put together. Okay, good. Somebody says in triangle A, B, C, and triangle. Now, if we
POR.
have A, B, C, good. We're going to need POR. Absolutely. So in triangle ABC and triangle POR, again, it's a proof of triangles, so we need 3 reasons. Right. Now, I'm actually going to skip a line. I'm going to skip a line here so that because we've got a little bit more work to do before we can say that anything is equal to anything. Okay, I'm going to start by saying in triangle ABC, angle A is equal to, who can tell me what angle A is equal to?
P.
No. We can't just assume
So
that. We need to work it out,
56.
right? It is equal to 56 degrees. How did we find that out?
We calculated the whole triangle, which is equal to 180.
Correct.
And
We used the interior angles of a triangle. So if I want to say that A is equal to 56 degrees, I first have to say that is equal to 56 degrees because I've used the interior angles of a triangle. Okay, that's the first thing I have to say. That's why ma'am's saying she has to skip a line. Okay, I first have to figure out what it is to make sure that they are actually equal. Am I making sense? So I can't make the assumption that they're equal if it hasn't been written in for me. Okay, so now that we've worked it out and we can just do a little 180 minus 90 minus 34, and that will indeed give us 56. I mean 56. Okay, after we've worked that out, then only can we say that angle A is equal to 56. Then we can start our proof, right? I can say angle A is equal to angle what? Yes, Michael, absolutely. Angle A is equal to angle P. That's it, Tseko, that's it, Palisa. It's equal to angle P, right? It's equal to angle P. And our reason for this, because remember we need statement and reason. Our reason is that we've proved it above. We've calculated it above. Okay, it's proved above. Okay, I'm going to skip another line. I'm going to skip another line. Let's go to angle R. Do you guys notice that we don't have angle R over here? Right? Oh, I'm lying. I don't have to skip another line. Ooh, teacher Coco, don't lie. Okay. I can say angle B is equal to angle what?
O.
Angle is equal to angle O. Good. Angle B is equal to angle O. This one's been given to us. They've told us that both of them are 90 degrees. That one's been given to us. Now, here is the nice thing about similarity proofs when you're using angle, angle, angle. If those two angles are equal to each other, what does this automatically mean about those two angles? That they are also what?
That they also have the same value.
Correct. They're also equal. Correct. And the reason for that, we're going to say, therefore, angle C is equal to angle R. And our reason is going to be because of the interior angles of a triangle. We can't even lie about it because both triangles will equal 180 on the inside. So if they only give us two sides or two angles, the automatic assumption, because they're both triangles, is that the other two sides or the other two angles will also be equal to each other. Now I can say, therefore, triangle ABC is similar to triangle POR. What is my reason here, guys? Angle, angle, angle. Okay, because we didn't use the sides, we used the angles. Absolutely, Palesa, good. Now that I've got that, let's look at our sides in proportion. I can then say that side AB is in proportion to side what?
PO.
PO, absolutely. AB is in proportion to PO. And I can also say side BC is in proportion with?
OR.
Yes, BC is in proportion with OR. And then I can do the last two. That means that AC is in proportion with?
PR.
Ah, that's it. AC is in proportion with PR. Okay, I'm going to give you guys one to do on your own. I'm going to give you guys one to do on your own. Oh, I don't like these ones. Okay, let's do this one. Let's prove D. Let's prove D. Okay, I want you guys to prove that the two triangles in this drawing over here are similar. But I'm going to help you guys out. Let's start. Okay, sure. Actually, let me do this, Desmarie. I'm going to move that one out of the way, and then I'm just move this one up so that we can work with both of them. Okay. Is that okay, Desmarie? There. I will leave it on the screen for you so you're with us. Okay, let's start with this one. Remember, guys, when we start, we're proving. So we're going to start by saying proof. In triangle, let's find our two triangles, guys. Where would I start?
ABC.
Okay, we'll say in triangle ABC, okay? In triangle ABC and triangle, where would we have to start with the other one?
AQR.
AQR.
That's it, beautiful. Triangle AQR, right? In triangle ABC and triangle AQR. Okay, I need 3 reasons. 1, 2, 3. Lucky for us, they've given us these 2 arrows, and these two arrows tell us that those 2 lines are what?
Parallel.
Parallel.
Yeah.
They're parallel, absolutely. And whenever we hear parallel lines, we think of
Fun.
Fun.
fun. Yes, we think of fun. All right. Let's look at number 1. Somebody, anybody, give us a shape. Do we see any of the shapes F, U, or N?
F. It's F.
Yes, it's F.
F, absolutely, it's F, right. There's an upside down F over there. Right, give me a statement. What is my first statement? What can I say? Angle. Which two angles are equal in that first F? Angle?
Q1
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 absolutely is equal to
and
angle.
B.
Yeah, that's it. Good. What is our reason?
Corresponding angles.
Yes, absolutely. Corresponding angles. Don't forget your parallel lines. I then have to say that QR is parallel to BC. Good. We've got one down. Do we see the other F?
Yes.
Absolutely.
C is
There it
equals
is.
to R1.
Absolutely. We can say angle C is equal to angle R1. And our reason for that?
Corresponding angles.
Corresponding angles. And don't forget to write your
BC is parallel to QR.
all QR is equal to parallel to BC. Both of them are correct. Well done. Stella. Absolutely. I'm missing one last reason. What would my last reason be?
That A is common.
Yay! Who said that?
It's me, man.
I don't know who me is. I'm sorry. Give me a name.
Fundamental.
Is it Tandameti?
Yes, man.
Ah, wonderful. Thank you, Tandameti. Yes, A is common. Well done. A is common. Right. We don't need a reason. When things are common, they exist in both triangles, so we don't need a reason for that. Now I can say, therefore, triangle ABC is similar to triangle AQR. What's my reason? What is my reason, guys? Good. These two are angles. Those two are also angles, and A is an angle. Good. So we can say A. There we go. Right. We didn't use the sides in proportion. Now, I want you guys to map out for me, using our two triangles, which sides are in proportion. Let's talk about that. We're going to start with the first two. AB over AQ is equal to, keep going, guys. What is that equal to?
BC over QR.
Beautiful, over QR, which is equal to?
AC over AR.
Ah, there we go. Just brilliant,